Now let's look at the first example problem for the stack topic. So this is a LeetCode problem called the evaluate reverse Polish notation. So in the problem, you are given a sequence of symbols. Each of them is either a number or a I guess a character which represent an operation. So for example, this is a one input sequence, plus, minus, and the star for multiplication. So reverse Polish notation refers to when you traverse this syntax tree of an expression, you do post-order traversal. So you output all the children before you print what's in the current node. So for example, this input sequence actually correspond with this syntax tree, which represent the expression. So looking at the tree, it's pretty obvious what we should do, right? Because this says we should add 2 and 1. We get 3, and then we subtract 3 from 4. 4 minus 3, we get 1. And then we do multiplication 1 times 3, so the answer should be 3. So once we have the tree, the structure is the semantic expression, and what we should do is pretty obvious. And to flatten this tree into a sequence of things without losing without introducing ambiguity. So post-order traversal is one way to do it. So for example, if we do post-order traversal here, we will first do 4, and then so for this node, so starting from the root, we first do its left children. So we are looking at this node, we do its left children, so it's a leaf, we output 4. And then we do its right children, this node. So because it's post-order, we first do its children, so left children is a 2, so we have 2 here. And after this, we do right children, which is 1. And then when both children are done, then we output plus. And then we output this minus. And then we go back here, but we first do the right child, output 3, and then we output this multiplication. It's a unit star here. So as we are going to see, these sequence uniquely determine the structure of the tree, because here, if we see the first operation plus, we know the 2 previous number are its 2 children. So then we know this 2, 1 plus correspond with 1 subtree, and this minus will be the 2 previous subtrees. So it will be this guy 2, 1 plus, and this 4, and so on. So one way to evaluate this sequence is to use a stack. So whenever we see a number, we push it onto stack. So we see 4, we push it here. We see 2, we push it here. We see 1, we push it here. And then whenever we see an operation here plus, we will pop the 2 element from the stack, in this case 2 and 1, and then we compute the result, so 2 plus 1 is 3, and then we push back the number. So after we process plus, we have 4, 3 here, and the next thing we see is minus, so we pop the 2 element, and then we do 4 minus 3, we get 1, we push it back in. And the next one we see is 3, so we have 1, 3 here. The last one we see is multiplication, star for multiplication. Then we pop 2 elements, 1 and 3, and do multiplication, and then put the result here. And at the end of the evaluation, if the expression is a correct expression, then we should have a single value left in the stack, and that is the value we want. That is the value of this expression. So let's look at the Java code. So here I actually use a stack, even though it's not recommended, but just to illustrate the concept of stack. So we create a new stack, and we iterate through all the tokens. if it's a plus, we pop two value x, y. So the top the top is y, the second one is x. So it doesn't make a difference for addition, but it make difference for subtraction. So then we compute x plus y, and then we push it back in. Subtraction, it's the second element we popped out minus the first element we popped out. So x minus y. Multiplication, division, it's the same. And otherwise, the else branch means that the string is a token, so we can convert it into integer and then push it in. And after we process all the tokens, we just return the value in the stack. So that's this problem.